This is the video lesson for solving proportion problems. The learning target for this lesson is, I am learning to solve proportion problems by substitution and comparison. The success criteria for this lesson are, I can determine when problems are proportion problems, and I can use substitution and comparison to solve proportion problems. So when are problems proportion problems? So we're going to look at some example problems and determine if they're proportion problems or not. So example problem number 1. If the mass of an object is doubled, but the mass of the second object stays the same, what happens to the force of gravity between the objects? Okay, so we want to know if the mass of an object is doubled, the second object stays the same, the mass stays the same, what happens to the force of gravity? Okay, so there's no numbers in this problem. All that we're asking is if we double the mass of one of the objects and the other mass stays the same. So this is a proportion problem because we can't know all of the numbers. All we know is what happens if the mass of one object is doubled. So example number 2, if the distance between two objects, so we have distance between two objects is cut in half, but the masses of the objects, so the masses of the two objects stay the same, what happens to the force of gravity between the two objects? So again, there's no mathematical way to solve this problem, no numbers involved. All we have is the distance between the two objects is cut in half. So we have to solve this using a proportion. And then our third example, so example problem number 3, if a car is going around a turn has a certain centripetal force, what will happen to the force if the radius of the turn is decreased by 1/4, but the car's speed stays the same? So we have the radius is changing, the speed stays the same, and we want to know what happens to the force. So there's no numbers to plug in. All we can do is change the radius and see what happens when it's decreased by 1/4 and the speed stays the same. So this is, again, a proportion problem. All right, so let's look at how to use proportions to solve these types of problems. All right, so step 1 is we're going to put a 1 in place of all the variables in the equation we are using. So let's look at the force of gravity. So we have force of gravity is equal to big G, mass 1, mass 2 over distance squared. So if we're trying to find the proportion of using this equation, we would say that F is equal to 1 times 1 times 1 over 1 squared. So that's the first step. Step 2. So we're going to write the equation again with 1 in place of all the variables except the variable that is changing. Okay, so let's say the problem said that mass 1 is doubled. Okay, so we're going to write the equation again with 1 in place of everything except for what's changing. So now we have F is equal to 1. So we have mass 1 is doubled. So now we have 2 times 1, and everything else stays the same. So okay, so now we have this situation. So let's look at step 3. So step 3 says that in place of the changing variable, write the changed amount. So we did that up here. So we wrote the changed amount for the changing variable. And last step is to find your answer. Okay, so we multiply all this stuff together. So we have 1 times 2 times 1. So that's 2 divided by 1. So our new force is equal to 2. So when mass 1 is doubled, the force is doubled. So that is how you solve proportion problems. All right, so let's look at a few examples. So example 1, if the mass of an object is doubled, so mass is doubled, but the mass of a second object, so the mass of a second object stays the same, what happens to the force of gravity between the objects? Okay, so our first step is to write the equation out in terms of where ones replace all the variables. So we have 1 for big G, 1 times 1 over 1 squared. Okay, now we want to say that one of the masses is doubled, the second mass stays the same, and then the force of gravity and the distance between them stays the same. So we say force of gravity is now equal to 1. Now we have times 2 times 1 over 1 squared. So that is equal to 2. So since the mass of one object is doubled, the force of gravity is 2 times as big. So the force of gravity is doubled when the mass of one object is doubled. Okay, example 2. If the distance between two objects is cut in half, but the masses of the objects stay the same, what happens to the force of gravity between the objects? Okay, so we have force of gravity is equal to 1, and then that's 1 times 1 over 1 squared, so that's equal to 1. All right, so now we have the distance between the two objects is cut in half. So now we have FG is equal to 1, and then that's times 1 times 1, and then that is cut in half. Okay, so now we have a half on the bottom of the fraction. So this then is multiplied. So when you have a fraction on the bottom of the fraction, you flip it over and multiply by the reciprocal. So this then is equal to 2. So we have the new force of gravity is equal to 2. So the old force of gravity is equal to 1. So when you cut the distance between the two objects in half, the force of gravity is doubled. All right, last example. So example number 3. If a car is going around a turn, has a certain centripetal force, what will happen to the force? So what happens to the force if the radius of the turn is decreased by 1/4, but the car's speed stays the same? Okay, so we have the centripetal force is equal to the mass is 1, and that's times 1 squared over 1. So that is just equal to 1. So now we're saying that the radius is decreased by 1/4. So we have FC is equal to 1 times 1 squared over, this is 1/4. Okay, so similarly to the last problem, if you have a fraction in the bottom of another fraction, so we're gonna flip this fraction over and multiply. So we can say that's times 4. So we end up with FC is equal to 4. So we had FC is equal to 1. Our new centripetal force is equal to 4. So if we had the radius of the turn is decreased by 1/4, the new force, the new centripetal force is 4 times greater than the old centripetal force. Okay, everybody, keep asking questions. It's how you learn new things.